So let's look at unlike fractions. What are unlike fractions? Very simple. If the denominator is same, we are calling it as like fractions. Unlike fractions, easy to remember. If the denominators are different, say something like we have 2 by 7 and say 4 by 5. These are unlike fractions because their denominators are not same. Denominators are different, then they are called unlike fractions. So what are unit fractions?
So,
Yes.
Fractions having 1 as numerator are called unit fractions, like 1 by 6, 1 by 7, 1 by 8.
Brilliant, brilliant. So all fractions where numerator is equal to 1. So when we have something like 1 by 7, 1 by 8, 1 by 12, 1 by 15, all these are unit fractions. Now, quickly, just to check your knowledge and your thinking ability, tell me out of these 4 fractions, which is a bigger fraction?
1 by 7. 1 by 7.
Very good. Very good. I like it. So, but I want someone to explain why 1 by 7 is greater.
Yeah, because in in unit fractions, where the smaller the denominator, the greater its value is.
Okay, smaller the denominator, greater is the value. My question is why, Bhavya? Oh, you don't know. Fair enough. Okay, so now let me give a chance to Priscilla. Priscilla, go ahead.
Sir, like taking the example of the pizza again. So, like if we divide a pizza into 7 pieces and you take one, it will be larger compared to like if you take a pizza and cut it into 12 pieces. Because when you cut it more, it becomes more smaller.
Brilliant. This is exactly what you're supposed to learn in mathematics. Just don't accept numbers like that. Just think about it. It's very simple. Very good job. Okay, so there's so much of pizza happening in our class today. So don't worry, I'll continue with pizza. Right? So if we have a pizza, so let's assume we divide into 4 parts of this pizza and we take one part of the pizza. Right? Now this is what we are taking. Just imagine we take another piece of the same size and divide it into 8 parts. Right? I'm very bad at drawing. Don't worry. Just get to the logic. So now out of these 8 parts, I pick up only one part. Now tell me which piece is bigger. Now if I take, let me change the color and let me look at it. So now this is the size of the pizza I got here. Right? Now this piece, I'll call this piece as 1 by 4. This piece of pizza is 1 by 4 and this piece of pizza, which all of you can see here, is the second piece. That will be 1 out of 8 pieces. Now tell me, if you look at this 1 by 4 and that 1 by 8, which looks bigger?
1 by 4.
So 1 by 4.
Wonderful. That's the reason your 1 by 4 is greater. So, so that's the easiest way of imagining and understanding why, if your denominator increases, the value of the entire fraction reduces. Say, for example, here what I'm trying to say is the denominator value is increasing to 8. Your 4 is becoming 8. So the value is going down. So now as 1 by 7 to 1 by 8, the size of the pizza will reduce. Therefore, 1 by 7 will be greater than 1 by 8, and 1 by 8 will be greater than 1 by 12, and 1 by 12 will be greater than 1 by 15. Yes, everyone, what is mixed numerals then? Or mixed fractions?
A fraction which can be expressed as a sum of a natural number and a proper fraction is called a mixed fraction.
Okay, brilliant. Good definition. So any fraction, when you write it, like generally it's an improper fraction. We have an improper fraction wherein we write an improper fraction as a combination of a natural number plus the fractional value. When you see 7 by 3 in the previous page, we understood 7 by 4. If you all remember 7 by 4, so like that we have an improper fraction like 7 by 3 here. So the 7 by 3, basically, if you can see this 7 by 3, now I can split this 7 by 3 as 6 plus 1 by 3. So basically, I will separate these 6 parts as 6 by 3 parts plus 1 by 3. Basically, 6 by 3 is actually 6 units. When you divide by 3, you get 2 units, right? So you have 2 full pizzas here plus 1 by 3. Basically, we write this as 2 1 by 3. That's how we write the mixed fraction 2 1 by 3. Yeah, so let's get on with equivalent fractions. What are equivalent fractions, anyone? So here is a square pizza. Now, if I divide this square pizza into 2 parts, so here this is 1 part and this is other part. So there's 1 each part and 1 part. So I'm shading this region. You can see 1 by 2 here, right? So 1 out of 2. And the same square pizza, if I divide into 4 parts, you can see there are 4 parts here. So here the shaded region is covering 2 parts, therefore it's 2 by 4, right? So the same shaded region, assuming it's a square pizza, now we have divided this into 8 pieces, and this 8 pieces, we have 1, 2, 3, 4 parts out of 8. So the same value, the same shaded region, if you can see, it can be written as 1 by 2. It can also be written as 2 by 4, because we have divided here into 4 parts and saying it is 2 by 4, and we have divided the same value into 4 parts, 8 parts here, and now we are saying it's 4 by 8. So if you look at whether it's 1 by 2 or 2 by 4 or 4 by 8, all these values are representing the same size of the pizza, which is half of the pizza. So can I say this 1 by 2 is equal to 2 by 4 is equal to 4 by 8? Yes, they are actually same values. But there's another way of looking at the same thing. Now let's look at the same thing the way Bhavya has defined the same thing. What she says is, if we have a fraction like say 1 by 2, now if I multiply this 1 by 2 with any number like say 2 into 1, she has multiplied the numerator, no, rather I am multiplying the numerator with 2, and also this denominator also with 2 into 2. And here I am multiplying the numerator with 4 into 1, and this denominator is 2. If you can see, I am multiplying 4 into 2. Now let's see how the numbers come up. So this is 1 by 2 anyways, is 1 by 2. Now 2 into 1 basically is 2 into 1. Instead of 2 into 1 is 2, and 2 into 2 is 4. Now 4 into 1 is 4, 4 into 2 is 8. So you can see we have 1 by 2, 2 by 4, 4 by 8 coming in, wherein we have multiplied with the same number in the numerator, that is 2 into, here we have multiplied with 4 and 4. By multiplying with the same number to the numerator and the denominator, the value of the fraction is not changing. That means if I multiply this with 5, that means I have 1 by 2. If I have 1 by 2, if I multiply the numerator with 5 and denominator with 5, I get what is called 5 by 10. Then even this is also equivalent to this value. If I multiply this 1 by 2 with some number like say 11, and denominator also with some number 11, the value will be 11 divided by 22. That is also equivalent to these fractions. So by multiplying with any number for that matter, if I do 1 by 2, I multiply the numerator with say some apple, and I multiply the denominator with another apple, with the same apple. So it is 1 into a is a, divided by 2 into a is 2a. So even this is also equivalent to the same fraction 1 by 2. So those are equivalent fractions. So here the point is, what you need to understand that the fractions, when the numerator and denominator are multiplied with the same number, the value still remains same. So that is something that you need to understand when you're understanding equivalent fractions. Everyone will understand definitions. I'm not worried about definitions. I want you to get the logic why they are equal, right? You know the logic now. You also know that you can multiply the numerator and denominator with the same value. The value of the fraction will not change. So for example, if we have any fraction, say something like 2 by 7. So if you multiply 2 into 4 and you calculate 7 into 4, therefore you get a value 2 into 4 is 8, 7 4 is 28. So I can say that 8 by 28 and 2 by 7 are equivalent fractions. They are exactly same fractions. And in terms of value, the value of the fraction still remains same.